So thanks for the introduction, and thanks to everyone for coming that early to my talk. So today I'm going to talk about a novel instrumentation framework called ARTIS, the Android Runtime Instrumentation and Security Toolkit. So this is actually joint work with my fellow colleagues from CISPA. So a few words about myself. I'm a PhD student at the CISPA Helmholtz Center IG, which is a large research site in Germany currently being built up. And my research focus is on Android security, in particular creating solutions that are working on the app layer only, so no changes to operating system and no flashing and so on. So I'm also a software engineer and occasionally a pen tester at the Buckets SRT company, and I'm a founding member of a local CTF team called SARSEC after Saarland University. So I'm a frequent conference attendee and speaker, mostly academic conferences like CCS, U6 and so on, but this year also things like DroidCon, and this is actually my first Black Hat talk. So I'm in general very passionate about all topics of related to security, any kind. All right, so let's actually start with a talk here. So given that I'm talking about app instrumentation, well, the first thing that might come to your mind is there are already frameworks that can do that. So quick question, how many of you do know XPosed and or Frida? Yeah, that's quite a lot. So in order to answer that question, why do we need another instrumentation framework, I'll very briefly explain how both of them are actually working. I will talk a little bit about their disadvantages and then move over to why ARTIS can improve upon the current state of the art here. All right, so very briefly, XPosed is a really great framework, and the basic idea is that it's overriding the so-called app process on Android. So the Zygody process is kind of the base process that is loading a lot of libraries, and it's kind of a pre-warmed app process, which means whenever an application is started, the app process is forked, and then the new application code is dynamically loaded. And the idea of XPosed is that they override this app process and add own code here, which means this code is carrying over to each single application and also the system server by definition. So the good thing here is we can hook apps and also the system server and other components on Android. But as promised, I will talk a little bit more about the disadvantages here, so we can actually kind of talk about how to improve here. So there's actually three things I want to talk about. The first one is performance, because to the best of my knowledge, XPosed is kind of hooking all methods and then multiplexing them through a single API, where it's checking if for this method there is a hook, and if yes, the hook is executed, and if no, then the original method is executed, so you lose some performance here. Second, talking about the granularity, the idea is that you can hook methods, but you cannot just exchange single instructions, which means it's actually not an instrumentation, but a hooking framework. And the third thing, and this came as a surprise to me, is that always all the modules are executed in each single app process. Which means if you have, for example, this Twitch ad blocker, which I suppose is an ad blocker for Twitch, this one is also run in the system server, in Twitch, but also your banking app, your Facebook, and your Twitter. And the basic idea here is that you execute the modules, and they by themselves have to decide if they want to run in the current process or not. So you put some trust assumptions here into the modules. So how do you deploy this? Actually, the basic idea is you flash this via custom recovery. So you need an unlocked bootloader, which is just not possible for all devices. And if I have a quick conclusion here, then we use XPosed for persistent modifications, kind of the modders. And this is only possible for power users, because you need this unlocked device and you need root, and it's not quite easy for the layman user. If we compare this actually to Frida, then we have a different approach here, because Frida is injecting the JavaScript engine of Chrome into running processes, so the V8. And here again, we can not only hook apps, but also any process. And that's actually a great thing here. But once again, I will nag a little bit about the disadvantages. So in this case, we have a performance loss because we're going through an additional virtual machine. And also granularity it is again, because this is a hooking framework, which means you have a really big method and you just want to change a tiny bit about that. For example, you want to kind of revert a condition or change a string or just replace any instruction. Then you have to hook the method, then actually rewrite the whole method in, for Frida, maybe JavaScript, and then change the single detail. So how is this deployed? Well, you either have this big Frida server running on your device on the root, and this is injecting the Frida stuff into running processes, or you add this by hand by using the so-called Frida gadget. But again, to the best of my knowledge, in both cases, you either need to disable SE Linux, or you need to kind of add additional whitelist entries for that and patch it. So in this case, compared to XPosed, we're talking about temporary changes because we're only doing this to a running process, and this is never persisted back to the file system. So this is more meant for kind of analysts and security pen testers and so on, not really power users or modders. Okay, so let's put those two in perspective. If we have a look at the installation process, we can soon see how actually both of them relate to each other. So everything on Android starts with an APK. We have the DEX bytecode, we have a signature on that, and then the signature is verified, and it's very important that after the signature verification, then the optimization kicks in and is creating kind of an optimized version of the app. So keep that in mind for later. Alright, so at runtime we have the app process, and it is forked for the app, and this app is loading this optimized version. So where is XPosed? Actually, as you can see, XPosed is, as mentioned earlier, in this app process, and forked, during the fork, it's carrying over to the app. Frida, in contrast, is operating at this point here because they're injecting into an already running process. And if you have a look here, both of them are working for actually running processes. In order to improve upon the current state of the art, we decided we want to lift this up one layer. So the idea here is that Artist is actually not running at runtime of those apps, but we have chosen this optimization step to be beneficial for us. And on devices running the Android Runtime, so everything from Android 5, this optimization step is guided by a tool called Dex2Ode. And I will now tell you what Dex2Ode is, what it's doing, and how we create Artists based on Dex2Ode, actually how we will improve upon the existing frameworks. So for the Android Runtime, Art, we have Dex2Ode as an on-device compiler. So this one is actually transforming the Dex bytecode of the application into a file format called OET. But don't worry about it, it's essentially an ELF file. So think about it, transforming the bytecode to actual native code, shared native library. And what it is doing, it is transforming the bytecode into a so-called intermediate representation, which is really a typical thing to do for a compiler. It is running state-of-the-art optimizations on that. So think about this IR as kind of a control flow graph of instructions per method. And then later, this is actually specialized by generating the platform-specific code. So keep in mind, this is running on the device, not on the developer side. So what did we do here? We took Dex2Ode as a base and then created Artist on it. So we essentially added two different parts here. On the one hand, you can see we added the pre-processing step. And I told you earlier that the signature is verified before the optimization. So we are now working with a copy of the original APK, and now we can merge any bytecode in there that we want. So assuming we have an instrumentation module with its own logic, then you have a Java library with all your business logic, and this one is merged in the first step. Then the whole code is transformed to the intermediate representation, and now we have this intermediate representation of the original app's code and also of our injected code. And now the second extension to Artist is coming into play, because we added new optimization passes. So we kind of tricked the optimization framework into executing our instrumentation stuff. So we kind of disguise as an optimization pass. And we use this one to reconnect, or kind of to connect for the first time, the target code and the code we are injecting. So first you add a complete Java or Kotlin library, and then you use those optimization passes to kind of stitch together your code and the original code. And the good thing here is that first, you're not breaking the app signature, which means you still get updates, because as said, the signature happens before this optimization step. Second, you have close to no runtime overhead, because there's no virtual machine, nothing running in addition on runtime, beside the fact the stuff that you're adding by hand. So this happens at install time or compile time. Third, this is really non-intrusive, because we are generating an alternative version of this OET file. So there's one in the system, there is one that we created, and just for this single step, we need root to switch both, which means from now on, when you start the application, the new OET file will be picked up and executed, and then you have the instrumented version running. And if you want to revert this, you just switch it back. And we're also not replacing the original Dex2Ode compiler on the device, but we're using our version of Dex2Ode or Artist in addition, but I will come to that in a minute. And the big thing here is that it's running on rooted devices, which means you don't need to unlock your bootloader, you don't need to flash anything, you don't have to change your operating system. This single step where we're replacing one OET file with another is the only time that we need root, because obviously executable code is in a protected location. Alright, so how do we deploy this? If you think of Artist as a command line tool, where you just input an APK and it outputs an OET file, then Artist GUI or wrapper app is the convenience wrapper around this. So it is searching for the correct APK, inputting it into Artists, and then pushing the new OET file to the correct location. And it has also some other functionality, like keeping all the instrumentation modules and Artists up to date. So this is something that we're working on currently. And you can import instrumentation modules from yourself or other developers and apply them. So we will see that later. So now that we have a basic idea about how all the three of them are working, we can compare them now. Let me first talk a little bit about the deployment here, because Artist is improving here a lot compared to XPosed and Frida. Because for XPosed, you need this custom recovery, which restricts you to certain devices where this is possible. And of course, you need the knowledge to do that. For Frida, you need a connected PC and an ADB connection. And again, the debug mode is not something that you want to have on a layman user's device. But for Artist, you're just installing an app. So assuming you have rooted your device, and there are ready-made applications that can just root your device, I think they're trying just a bunch of root exploits, then you can just go ahead. So this is also not only meant for experts, but also for layman users. You can just install it, Artist GUI, and use it. Talking about the invasiveness, so the extent to which you're changing the operating system, well, Artist definitely improves upon XPosed, because you're not changing part of the operating system, you're just changing this compiled version of the application that you're instrumenting, not all the others. And depending on if you want persistent changes or non-persistent changes, then either Frida or Artist wins. Talking about the granularity here, Artist is the only framework that can operate on the instruction level. And the reason is that we have this intermediate representation. And as I said, this is a control flow graph of instructions. And you can just think of this as you have one kind of object-oriented representation of each single instruction. So you can just create a new one, exchange them. You can essentially do whatever you want to the code. And talking about module updates, well, for XPosed, if you want to have a new instrumentation module, you have to reboot the device. For Artist, you actually just have to import this and recompile the target for which you want to apply this. So it's a bit better here, but the clear winner is Frida because they're loading JavaScript and you can do this at runtime, right? But there's one big thing, since we're relying on the Android Runtime, which was introduced in Android 5, and we're relying on a particular component called the optimizing backend, which was only stable from Android 6, we cannot support anything before that. Alright, so I hope that at this point I could convince you that Artist is aiming for kind of a sweet spot here, because we have quite easy deployment, we have a fine granularity for the instrumentation, and also we are non-invasive, which means it's also harder to detect Artist on a device. So there's one particular model that I want to showcase to you. May I ask you to quickly show of hands, who ever heard of the Stevo library from Facebook Engineering? Alright, we have one here. Well, that's actually pretty great. So the basic idea is you have your own application, you add it to the debug version of your app, and this library is connecting your app to the Chrome developer tools running on your PC. So you can now debug your app as it was a web app. So you see all the files, you see the database, you can even execute JavaScript. So what do you think happens if you inject this into arbitrary processes? So this is actually the demo that I prepared here. Let's see if that one is working. So you can see my device, right? Yes. Okay, so you have to trust me here that I'm not a developer of Reddit, so I don't have the code here. But I instrumented it before the talk for time reasons. And if I start Reddit now, you see in the Chrome developer tools here, we can inspect it. Let me arrange this because it never stays as it should. Alright. No. Now we have it. Okay, so the first thing you're seeing is that we see the UI of Reddit. And let me speed this up a little bit. We can search for this welcome string we see. And where is it? Here it is. And we can change it. So if you have a look at the left side here, well, it's a neat little trick, but I have complete control over the app. I can actually show you a more interesting thing, which is the network tab here. So if I just start loading content here on Reddit, then you can see all the traffic coming in here. And we don't care about encryption because we're directly getting this from the application. So we're subverting all kinds of, well, pinning and encryption and so on. And you can see all information that you're used to, like the headers, the responses. And for pictures also you see the preview. And actually my favorite thing to do here is the resources tab. And don't get confused by the name. They're obviously meant for the web. But you see all the files of an application here. You can inspect them. And my actual favorite part here is you can look at the databases of an application. So let me have a look at this Reddit share database and the subreddit info table. And the Reddit users among you might recognize the subreddits we have here. And we have this nice, can you see it? Whitelist row here. And it says actually for which subreddits you have how many and what kind of ads. So I'm pretty sure if I would dig into this a little bit, it would be quite easy to write an ad blocker for Reddit. Just saying. All right. So this is one of the things you can do with Artist, and of course you can do a lot more. We created, for example, in an original paper, an intra-app taint tracking system that would just inject all the code using the compiler to track information through an application. Together with my colleague Ji Huang, we created a quite impressive system called Compartist, where we are compartmentalizing single libraries. So in our case, we took an application with an add library. We took out the add library completely. We moved it to a different application. So now instead of calling from the app into the library, it is an inter-process communication. So we created a custom binder protocol to connect them again, and the add view is displayed on top of the running application. So now from a design perspective, you have two distinct security principles, which means you can revoke permissions from the add library, but the app still has it. And also the add library cannot access the files of the application. And we've done a bit more here. We have created inline reference monitoring approaches, method tracing, so on. And if you want to, you can also use Artist to replace the system compiler. Then you can also re-instrument the system server and the boot out file, and so the kind of the framework classes of Android. So whatever runs on Java on Android is compiled through dex2out. So this is within reach for Artist. We're actually currently working on doing this from our Artist GUI wrapper, so you don't have to create a custom ROM, but this is a work in progress. All right, so I've been talking about modules for a while now, and let me be sure we're all on the same page here. So for Artist, actually module is kind of an abstract functionality that is self-contained, so it needs at least 3 different things. First, the so-called codelib. This is the version with the Java library with business logic that I mentioned in the beginning, and this one is merged in the very beginning here. Second, we have those optimization passes, which are essentially kind of stitching together the code. This is a shared object that you have in your module. And then also you have some meta information like who's the author, what is the version, and so on. I'm going to use that in the future. Go on. Yeah. So if you're interested now, it's quite easy to create modules with Artist. So we created module SDK. Essentially, it's something like 60 megabytes. You can download and install it. And then we have a template module and codelib available. You can just kind of start from that and create your own logic. And after that, we have ready-made build script. You just have to hit make, and it's done. And it creates a zip file, and this one can be imported into Artist GUI. So all of this is actually open source. And as you can see on the right-hand side, I applied this to the Black Hat USA app, and it works like a charm. So you can actually see how the application looks like. For each single app on your device, you can choose which modules to apply, remove the instrumentation, re-instrument, and so on. So kind of the convenience. I think I have time to quickly show how this looks. So let me switch to something different here. All right, so I will now kill this app. And once again, I already instrumented Black Hat USA app. And when I start it now, you can see that it logs the name of each single method that is invoked to logcat. So of course, this is again a toy module, but it's kind of interesting to see what your applications are doing, particularly if you instrument all of them and see what's happening in the background. So for this app, for example, it's, well, what do we see? Sync engine, a lot of data classes. If I start something, well, it's executing quite a lot. So you can see why it takes some time for loading. All right. That one. So what is the current state here? The basic idea is we just created this Artist module SDK and have some module management in our Artist GUI app. And we have some semantic versioning and documentation and so on. And all of this is open source, so you can check it out. And we want to improve upon this, of course. We want to have automated releases and testing. We want to have a public module marketplace where you can create modules and upload them, just similar to what XPosed is offering right now. And actually, one of my students is working on creating a layer between XPosed and Artist, so you can actually reuse XPosed modules, at least some of them. So I think for now it's like 1,200 modules for XPosed. It would be nice to kind of reuse some of them to bootstrap the whole thing for Artist. And as I said, I want to implement a system server and framework support, so we can just instrument them from any rooted device. All right, so since it's pretty early, if you slept through the whole talk, this is the perfect time to wake up now, because I have 3 takeaway messages for you. The first one is Android instrumentation analysis is fun. I hope I showed you that with the Stellar module. Second, Artist occupies a sweet spot here because it provides some advantages that XPosed and Frida cannot offer. And third, Artist is completely open source, and we're pretty early in this phase. So if you find this interesting, if you want to get involved, well, drop me a message. We have a Jitter chat, we have GitHub, I have Twitter and Keybase, whatever. So just send me a message or my team, and we're happy to talk about this and answer questions. So at this point, thanks again to all of you for coming that early, and I'm happy to take your questions now. So if you have questions, there are microphones there. I will try to repeat the question, and I think we have some time left for questions. All right, so thanks a lot.